Taking a look at these last few problems, it says that we need to write a possible equation given the graph. So now we're working backwards from graph to equation. We're going to take a look at 16 because that's a little bit challenging. When you see this graph here, you recognize that simple curve, and you can imagine if you flipped it over and moved it to the center, it would look something like that. Now, I know that the square root function and the log function both look kind of similar. They both slowly work their way up. One thing about the square root function is it's going to stop. The logarithmic function, on the other hand, is going to never stop, and it's going to be also a little bit steeper. If you notice the pattern of over 1, or down 1 over 1, down 1 over 3, down 1 over 5, things like that, that's going to be quadratic. And if it stops, it's going to be quadratic, or, well, the square root function. So if we're trying to figure out an equation for this now, we see that this graph is flipped upside down. So I know that my basic parent function of y equals square root of x is being modified in some way by flipping it upside down. Now if I took the standard square root function and sketched that, it would look something like this. And if I were to flip that upside down, the y equals negative square root function, it would take the whole thing and mirror it over the x-axis, and it'll look something like that. Now, the last thing it looks like I need to do is bring it up 2 units so that I can end up matching the graph I was given. So I have y equals negative square root of x, and I need to bring the whole thing up 2 units. So based on my knowledge of graphing transformation, a possible equation for this would be y equals negative out front square root of x, and then outside of the square root symbol a plus 2 to bring it up 2 units. If I extended my square root symbol like that, that would actually move it to the left 2 units instead of up 2 units. So make sure you stop your square root symbol. Apply those for the other equations here. The other one we're going to tackle is number 19. We're doing the same thing. We're told to sketch the parent function and its transformation given the equation. So it's the opposite direction of what we just did, but same idea. Parent function here, I see an x cubed built in. So let's write out y equals x cubed and sketch that graph. I know I have a point at 0, 0. At 1 and 1 cubed is 1. At 2 cubed is 8, so that's already kind of off the graph. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8, so that's also off the graph. So really we have this going on, and we never quite reach 2 or negative 2 in the viewable part of our graph. Now the negative sign right here is going to modify this by flipping the whole thing, mirroring it over the x-axis. So 0, 0 still applies, but what used to be 1 positive 1 is now going to be 1 negative 1. And then the same idea back here. And so our whole graph just gets modified like that. We don't have anything directly modifying x in parentheses, so we get to skip that part. What we do have is a minus 2 out front, which is going to drop the entire graph 2 units. So if we start from where we were and move down 2 full units in every spot, we will end up here. And then because we moved down 2 full units, going up 8 will finally be possible, so we will be able to actually cross the line x equals negative 2. Leaving our graph looking something like this. That isn't perfect, but it takes the original green-yellow graph that I drew, we flipped it with the negative to get the orange, and then we applied the drop down of negative, or of 2, which got us the black graph. And finally, let's take a look at the last page just real quick. All you're doing is matching equations and graphs. You'll see that you have some absolute value problems, you have some cubic, and you have some square root all going on here. And so each one of these equations belongs to one of these graphs. So first figure out your parent functions. For example, with a and b, they're both absolute value. 24 and 25 are both absolute value. So you know that one has to belong to one has to belong to the other. Then you just have to decide when it's in the parentheses or in the absolute value symbol, does that cause it to go left and right or up and down? And B, when it's outside, does it cause it to go left, right, or up and down? So once you work that out, you should be able to narrow down your choices pretty quickly. Good luck.